Hello students, in this particular tutorial we are going to discuss regarding numericals associated with static indeterminacy of trusses and rigid plane frames. In previous class we discussed the numericals associated with beams. Clear? Now we move on to trusses. So this is also similar to case of beams, but here the internal member forces and joint equilibrium conditions are a little bit different. In case of beams, internal member forces are 2m, but in case of truss, that is only 1m. Clear? And also the joint equilibrium condition, both in case of beam as well as trusses are 2. Clear? Those things already we discussed in introduction classes. Now we move on to the numericals associated with trusses. Clear? So what I have already discussed regarding this is associated with number of member forces. R is associated with number of external reactions. J is associated with number of joint equilibrium conditions available. In case of truss, that is 2J. Clear? And this is external indeterminacy. It is given by equation E equal R minus 3. So in step 1, we are determining the required parameters of a given truss. What are required parameters? M number of members, J number of joints, and R number of external support reactions. Those are required parameters to compute total degree of indeterminacy. Clear? We move on to first problem. So in first problem, we just compute required parameters. See how many number of members present in the given truss. It is AB 1, 2, 3, 4, 5 and 6. Totally 6 number of members. How many number of joints? At joint A, hinge is provided, therefore 2 external reaction. At joint B is roller is provided, hence 1 external reaction. Totally 2 plus 1, there are 3 external support reaction. How many number of joints are there? A, B, C, D. Totally 4 number of joints. So once you computed required parameters, then substitute in final equation I equals M plus R minus 2J. You are getting I equal 1. Now compute external indeterminacy using equation R minus 3. You are getting 0. Internal indeterminacy, total indeterminacy minus external indeterminacy. You are getting 1. So the given truss is internally indeterminate to degree 1 and externally determinate. So this is very simple. This is the same steps whatever we followed in case of beams. The only changes we are changing the empirical equation. In case of beam, that is 2m plus r minus 2j. Here you are using m plus r minus 2j. Clear? Next, we move on to second problem. In this second problem, how many number of members are there? Just count the members. 1, 2, 3, 4, 5. Totally, there are 5 members. How many number of joints are there? Similar to previous problem, there are 4 joints. A, B, C and D. There are 4 joints. How many external support reactions are there? At A, there is a hinge joint, therefore 2. At B, also hinge joint 2. Totally 4 support reactions. Now substitute these parameters in final equation m plus r minus 2j. You are getting 1. Compute external indeterminacy using E equals r minus 3. You are getting 1. So internal indeterminacy will become total indeterminacy minus external indeterminacy. It will become 0. Hence the given truss is internally determinate and it is externally indeterminate to degree 1. Clear? We move on to next problem. In next problem, count the number of members. 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally here there are 8 members. Therefore number of members are 8 plus 1, 9. Sorry, there are 9 members. Clear? How many number of joints are there? 1, 2, 3, 4, 5, 6. There are 6 number of joints. How many external reactions? At A, I am having hinge support. Hinges will develop 2 external support reactions. At B, I'm having roller, only one external support reaction. Therefore, totally 2 plus 1, 3. So, using these parameters in final equation, we are getting 0. Therefore, it implies both internal as well as external indeterminacy is 0, because total indeterminacy is 0. Matlab both I and E are 0. Hence, the given truss is determinate truss. Clear? So, like we move on to next type of problems. It is associated with rigid plane frames. Rigid plane frames. So in this case also it is similar to whatever the empirical relation we used in case of beams and trusses, but here we are using, yeah, m number of internal member forces, that is 3m in case of rigid plane frames, r number of external support reactions, whatever the external support reactions developed in the frame members, and j number of joint equilibrium condition. In case of rigid plane frames there are 3j. Clear? And also external indeterminacy is determined using equation r minus 3. Okay, for m number of members, j number of joints, r number of support reactions, the total degree of indeterminacy for a rigid plane frame is given by I equal 3m plus r minus 3j. Clear? Now we move on to steps one by one for a particular problems. The step 1 is clear. Compute required parameters. Step 2 is whatever computed parameters you just substitute in the total degree of indeterminacy equation. Next, compute external indeterminacy. Using total indeterminacy and external indeterminacy, compute internal indeterminacy of the member. Clear? Now we move on to first problem. In first problem, at joint A, fixity is provided. Therefore, VA, HA and MA, there are three reactions. At joint B is also fixed. Therefore, three reactions. Totally, how many number of external support reaction? 3 plus 3, it will become 6. First count, how many members are there? There are AB, AD, DC and CB. 3 members. Number of members? 3. How many joints? 1, 2, 3, 4. There are 4 joints. How many total number of external reactions? 6. Clear? Use these whatever the parameters in final equation. 3m plus r minus 3j. You are getting 3. Now compute external indeterminacy, that is r minus 3, that is 3. Hence the given rigid plane frame is externally indeterminate of order 3 and it is internally determinate. Why? Because internal indeterminacy is 0. That's why this is internally determinate but externally indeterminate. Clear? Next we move on to second problem. It is also similar to previous problem. So first count the number of members. 1, 2, 3, 3 columns, 4, 5, 2 beams. Totally 5 number of members. How many joints? 1, 2, 3, 4, 5, 6. There are 6 number of joints. How many external support reaction? At joint A we are having hinge support. Hinge support will develop 2 support reactions. At B we are having fixity, therefore 3 support reaction. Once again at C we are having hinges, therefore 2 support reactions. Totally 2 plus 3 plus 2, 7. So totally 7 external support reactions. Clear? Use these parameters M, J and R in final equation. 3m plus R minus 3j. We are getting 4. Therefore the total indeterminacy of given plane frame is 4. Now compute external indeterminacy using equation E equal R minus 3. It will become 4. Hence the given structure is externally indeterminate of degree 4 and it is internally determinate. Why? Because internal indeterminacy is 0. That's why it is internally determinate but externally indeterminate to degree 4. Clear? Next we move on to multi-story problem. This is also similar to previous problem. Now count the number of members. So here 1, 2, 3, 4, 5, 6, 6 columns and 4 beams. Totally 10 number of members, 10. Count the number of joint. In each vertical plane we are having 3 joint, 3 joint, 3 joint. Okay, totally it will become 9 joint. Next count the number of total external support reaction. A, B, C. in all we are having fixed supports, then it will become 3 plus 3 plus 3, totally 9 support reaction. Use these parameters m, j and r in final equation. 3m plus r minus 3j, we are getting 12. So total degree of indeterminacy is 12. Now compute external indeterminacy using equation r minus 3. You are getting 9 minus 3 equals 6. Now compute internal indeterminacy using equation total indeterminacy minus external indeterminacy. We are getting 6. Hence the given rigid plane frame is internally and externally indeterminate to degree 6. Clear? The given multi-story frame, two-dimensional frame, is internally as well as externally indeterminate. Clear? Okay. So in this particular class, we discussed regarding plane frame trusses, that is pin jointed plane trusses as well as plane frames. Clear? Now, if you are having any doubts, please contact to mail ID. Okay. Thank you.